Good morning, guys. I am Eric Khan Bolos. I am first year student of Bachelor of Physiotherapy at Marwadi University. My today's subject is uh, physiology, and in physiology, my topic is saltatory conduction. Hello, everyone. Today, I am going to explain saltatory conduction, a rapid and efficient way in which nerve impulses are transmitted in our nervous system. Introduction to the nervous system. Introduction to nerve impulses. Let us begin with the basics. A nerve impulse is an electrical signal that travels along the neurons. It's how our brain communicates with the body. The speed of this conduction is very important, especially for quick action like reflexes or reactions, and that's where saltatory conduction comes in. Now we can go for the myelinated and unmyelinated neurons. There are two types of neurons. Myelinated neurons have a myelin sheath and conduct impulse faster. Unmyelinated neurons lack this sheath and conduction is slower than myelinated neurons. Unmyelinated neurons lack of sheath and conduction is slower. Uh, the key structure of difference is presence of Schwann cell and myelin sheath is myelinated neurons, which helps in rapid signal transmission. Now we can go for what is saltatory conduction and what is the importance of saltatory conduction. Saltatory conduction means the nerve impulse jumps from the nodes of one wire to the next rather than moving continuously. The word saltatory comes from the Latin word salter, meaning to leap. This leaping mechanism helps speed to transmission. Mechanism of saltatory conduction, how it works. The node of runway are smaller gaps between the myelin sheath along the axons. Myelin acts as a insulation, so the impulses doesn't travel smoothly. Instead, it jumps from node to node. Depolarization, which is the changes in electrical charge, happens only at the nodes, making the process much faster. Ionic movement in saltatory conduction. Now let's look at ion movement. The channels for sodium and potassium are only active at nodes. This allows for rapid depolarization and repolarization only where it needed. That's why saltatory conduction is also very energy efficient. Fewer ion pump are working. Diagram of saltatory conduction. Here's a simple diagram showing that process. We can see the myelin sheath and nodes, how the action potential moves in jumps. This is the clear presentation of how efficient signals move in myelinated neurons. Advantage of saltatory conduction. There are many advantages. It increases speeds. Increased speed. In fact, signals can travel up to 100 times faster. It saves energy since fewer ion channels and pumps are needed, and essential for quick reflexes and brain function like thinking and coordination. Disorder affecting saltatory conduction. When this process is disrupted, problems occurs. For example, in multiple sclerosis, the myelin sheath gets damaged, which slows down the block's conduction. This leads to symptoms like muscle weakness, vision issues, and more. Comparison table. Let's quickly compare saltatory and continuous conduction. Saltatory conduction needs myelin, continuous doesn't. Saltatory is faster and energy saving, while continuous is lower and use more energy. In saltatory conduction, the action potential occurs at nodes, while it continues, it happens along the entire axon. Conclusion. To wrap up, saltatory conduction is a vital process that ensures rapid and efficient nerve impulses transmission. It relies on healthy myelin sheath and nodes of run wire and essential for proper nerve system function. Thank you.